Okay, so what we're doing in this section is we're going to start learning how to graph exponential functions. In order to graph an exponential function, we need some information about it. An exponential function is a non-linear function in the form of y equals a times b to the power of x. What makes it an exponential function is that the variable is in the exponent. So when your variable is in the exponent, that makes it exponential. Okay, here's some rules that can happen. A cannot be 0, B cannot be 0, and B has to be greater than 0. So it has to be a positive number. We can't have negative numbers here. A lot of times the way you're going to see it is you're going to see it with something in the parentheses. And that number in the parentheses cannot equal a negative. Okay? Alright, as the x value changes by a constant amount, so x changes by the same amount, the y value is multiplied by a constant factor. Okay, so a linear function was the x and y changed by a constant amount. But for this one, exponential, what happens is the x changes constant and the y is multiplied. So let's see. Let's see if this is exponential or linear. So to get from 0 to 1, that's plus 1, plus 1, plus 1. Okay, so that changes by a constant amount. Let's try this one. This one's plus 3, plus 6, plus 12. Okay, so that doesn't work because it's not constant. But let's see if multiplying works. Let's see what happens if I multiply. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So this is exponential. Okay. All right, here, let's try this next one. Let's check the x's first. Plus 2. Plus 2, plus 2, 9 from 7 minus 2, minus 2, minus 2. So both of them are adding or subtracting, and so this is actually linear. So for linear, you add or subtract both. For exponential, you add or subtract on the top for the x's, and then the y's are multiplied by something. Alright, so now what we need to do is we need to look and see what this graph looks like. Okay? Whenever I have a value greater than 1, a b value greater than 1, this is called growth. We will spend a lot more time with it, but I want you just to recognize when the b value is greater than 1, it's growth. When the b value is between 0 and 1, so it's smaller than 1, it is called decay. Alright. When we have this, the a value is where we cross the y-axis. So whatever the a value is, that's where we cross the y-axis. Okay? When it grows, what happens is it starts near 0 and it grows and gets bigger and bigger and bigger. So it gets to be a steeper curve. So growth is going to grow away. So growth, go away from axis. And it's the x-axis. Okay? Decay. Decay is it gets smaller and smaller. So it starts big and then it decays. It gets smaller and smaller. Okay, so decay kind of, it doesn't necessarily go down, it goes towards the axis. I don't have any nice little things to help you remember, but just growth is go away. Okay, decay goes towards. All right, so now let's actually do some evaluating and then we'll do some graphing. So to evaluate it, I just have to plug this in. So x is 2, x is 5, and x is 1/2. And you're going to need your calculator for this because we're going to get decimals for some of these. And so it's just going to be 2 to the 2nd, which is just 4. 2 to the 5th, which is 32. And 2 to the power of 1/2, which is 1.41. Okay, so those are the answers. All right, when we do number 2, we need to do, 2, 5, 1/2. So it's -2, 3 to the 2, -2, 3 to the 5th, -2, 3 to the 1/2. Okay, so if you wanted to do this by hand, you could. You would have to do 3 squared first. You don't do 2 times 3. You do exponents first. So that's 9. And 9 times -2 is -18. I don't know what 3 to the 5th is, so I'm just going to plug this whole thing in the calculator. And so I get -486. And then the next one I'm going to plug in the calculator, -2 times 3 to the power of 1/2, which is -3.46. And those are the answers for that one. Okay. I'd like you to try the third one on your own. Once you think you have it, go ahead and press play. Okay, so 1/3 times 0.5 to the 2nd, 1/3 times 0.5 to the 5th, 1/3 times 0.5 to the 1/2. So these are decay, and so from 2 to 5, it should get smaller. Okay, so let's see, 1 divided by 3, 0.5 squared. This is 0.083. 1 divided by 3, 0.5 to the 5th, 0.01, and then 1 divided by 3, 0.5 to the power of 1/2, 0.24. Okay? So these are just substituting, and you use your calculator to help you find it. All right? When we do some graphing down below, we're going to have to use this process again. All right, so let's graph this and then determine the range and domain. All right, so this number is 3, so I know it's going to cross at 3. This tells me that it's, because this is greater than 1, it tells me that it's growth. So it should start out kind of flat and then grow away from the x-axis. So what I'm asking you to do here is probably pick a point to the left and then maybe 2 points to the right, so that way, well, actually we'll do 2 to the left, 2 to the right. So let's do -1, -2, 1, and 2. So 3, 2 to the -1, 3, 2 to the -2, 3, 2 to the 1, 3 times 2 squared. Okay, so let's see what we have with all those. And so we get 1.5. So -1 and 1.5 is right about here. And then we're going to do 2. And that's 0.75. So -2.75. And then this one I could do 2 to the 1 is just 2, so this is 6. So it's way up here. And then 2 squared is 4, times 3 is 12, so this is even higher up here. So it's going to kind of flatten out, and it's going to go up. Okay? All right, so do I have space for domain and range? Yeah, I do. So let's change colors for domain and range. So the domain is my x value, and there's x's going to the left and to the right, so this is all reals. The range value, it actually is everything above 0. It gets really close to 0, but it never touches 0, so it's greater than 0. Don't make it equal 0 because it's never actually going to come to 0. Okay? All right, I'd like you to try 5 and 6 on your own, picking, you know that this first number right here tells you where it's going to cross the axis, and then you're going to pick numbers and you're going to see what happens with it. So pick 2 numbers to the left, so we'll always do -1, -2, 1, and 2, and then we'll see where we go from there. Okay, so this one is down here, but this is still growth. So this is going to go away. And so because my axis is above it, to go away from it, now it's going to go down. So that's why I never talked about it going up or down, because it depends on where it's at. Growth goes away from the axis. So it should follow this pattern where it's close to the x-axis and then it's going to drop off. So -1/2 times 3 to the -1 is -0.17. So -1, -0.17. That's pretty close. And then this one is even closer. It's -0.06. So I'm going to try and get a little closer. Oops. Okay, now let's try the positives. 1/2, 3 to the power 1 is just -1.5. I zoomed in by mistake. So 1, -1.5, and then let's try 2, -4.5. So 2, right about here. So it goes down pretty steep. Okay? All right, let me fix the window. Okay, so let's look at the domain for this one. The domain, it's still x, and it's still going left and right, so the domain is all reals. This time the range is going down, and it's going down from 0, so it's less than 0. It doesn't equal 0, but it goes below 0. Okay, let's see what you did for number 6. Okay, so you should have plugged in -1, -2, 1, and 2 again. I know that's where it crosses. So it's crossing here, and this shows decay. So decay goes towards the axis. So since it's above, it's going to go down towards the axis. Okay, so when I plug in a -1, I get 4. So -1 is with 4. When I plugged in a -2, I got 5.3. So that's a little bit higher. When I plugged in a 1, you get 2.25. And then when I plugged in a 2, I got 1.69. And so it's going to kind of go down, and it's going to keep curving out, and then it's going to flatten out here. Okay, so domain. Again, domain, same thing. It goes left and right all ways, so it's all reals. But the range for this one, it's above the axis. So that means y is greater than 0. Okay, so what we have is we have our exponential function. Remember, it's exponential. My thing to go over there. Remember, it's exponential. There we go. It's exponential if x changes by a constant, but the y changes by multiplying. Growth goes away from the axis. Decay goes towards the axis. Might be helpful. Let's draw what the other one would look like. This is if A is positive. If A is negative, it's going to go away from it. So that might be helpful. Let's have both there. A is negative. And so this one again, A is positive. And if we have an A is negative, it's still going to go towards the axis, but it's going to go up towards the axis. So that's a helpful thing that might be important for us to have, because it gets a little confusing. You can't think about it as going up or down. You have to think about it as going away or towards the axis.